Hi everybody, welcome to the 6.9a notes. They say 6.9 at the top. These are going to be first of these kinds of notes, and these notes today are called integrating using substitution. So I don't know if you guys have noticed this so far, but when we've been taking antiderivatives, when we've been using the definite and the indefinite integrals, we have not yet had any functions that were compositions. We've had some functions that were products and some functions that were quotients, but in both of those situations we were able to get rid of the product quickly, the quotient quickly. But say we're not able to do that, or we have a composite function, we have to use another strategy, and today's strategy is called, like I said, integrating using substitution, but also sometimes you hear this called U substitution. And really what it is it's kind of just the reverse chain rule. So I'm sure you're glad to hear that, but I'll go through the procedure real quick and then we'll do some practice problems. So essentially for this, you are going to, just like you kind of did when you were doing composite functions, you are going to call something an inside function. So the inside function we're going to call U, and then you're going to take U and you're going to take the derivative of it. Then you're going to find dx. That will make more sense. You'll substitute the u expression for x expressions. You'll integrate, and then you'll substitute back to get your final answer. So it's going to be kind of confusing, but we'll get the hang of it. Today we're going to do indefinite integrals, and then tomorrow we'll do, or later this week, we'll do indefinite. So here's just like an easy problem right here. We look at this function right here. It's the integral of 5 times 1 plus 5x cubed to the dx power. Now, if we wanted to do this without u substitution, we would just have to multiply this right here 3 times, which is doable, but not exactly what we want. So what we're going to do first is, this is a composition, right? We have an inside function, which is 1 plus 5x, and then we have this outside function. And so I'm going to assign something a u. And so in this case, u is going to be the inside function, which is 1 plus 5x. Then what I'm going to do is I'm going to take the derivative of this. So I'll do 2 equals the derivative of this, so du dx, that's going to equal 5. So I have taken the derivative of that. Now this next part is going to be kind of weird. So I'm just going to write a note, right? I took the derivative of my inside function. Derivative of inside. So that was my step 2. My step 3 is going to be kind of weird. And essentially what I'm going to do, and it will make more sense, is we are going to solve for dx here. And in class, when we get back from class, we're going to talk more about like why do we do these procedures, but for right now what we're going to do is we're going to solve for dx. And so the easiest way to solve for dx in this problem, we're just going to kind of treat it as if it was a variable. What this notation means, it's the derivative of u with respect to x. But what if we just like mess around with these things a little bit? So what I'm going to do is I'm going to multiply both sides by dx. These cancel out. I'll get du equals 5 times dx, and then my goal here is to get dx alone, so I'll divide both sides by 5. And so I'm going to get du over 5 equals dx. And so I have effectively solved for dx. And so what that allows me to do is I'm going to go back to my original integral, and I'm going to do some substitution. So I'm going to change this expression 1 plus 5x. I'm going to plug in u there because I want to make this in terms of u instead of in terms of x. And then I'm also going to replace dx with what dx is now, which is du over 5. I will simplify that up a little bit, so these 5s will cancel out, and I'll get u cubed equals du. And now you notice we don't have this composite function anymore. We just have one variable to the third power. And so because of that, we can use the reverse power rule. 1, 2, 3. Oh, sorry. I was like, where did I count wrong? This is 4. Okay, so reverse power rule. So this will be u to the 4th power plus 4 plus c. And then my final step is I need to plug everything back in. So did I skip? Yeah, substitute back in. So I assigned u to be 1 plus 5x. I put that to the 4th power divided by 4 plus c, and that is my answer right there. And so what u substitution allows us to do is just essentially temporarily redefine variables. And by doing that, we're like, well, why can we do that? Essentially what we're doing here is we're using the the chain rule, right? If you remember, we always multiply when we're doing the chain rule. We always multiply by the derivative of the inside. And that's what we still end up doing when we plug it in here. We just do it kind of in a different way. And again, when we get into class, we'll talk more about the whys of this, but we're just going to try to get the procedure down first. So here's another one. This one is maybe a little bit more tricky, but just a reminder. Well, I'll get there in a second. First, we just have to define what our u value is. So u is going to be x plus 2. So that's our u value, and then we'll start by taking the derivative of both sides here. So I'll get du dx equals 1. And then same thing, I'm going to solve for dx. So, I mean, really what you're doing is you're just kind of always flipping these two people's places. So you're going to multiply dx on both sides, right? Du equals dx, and there's a 1, but I mean, you don't have to write that. So that's what you're going to get here. You're going to get du equals dx. Then I'm going to come here, I'm going to substitute, so it'll be secant squared u, and then instead of putting dx, I'm replacing that with a du. Now I'll take the antiderivative, and then just a reminder up here, the antiderivative of secant x dx is going to be tangent x plus c. So we're using u's this time instead of x's, but this answer is going to come out to tangent of u. Don't ever forget that c value if we're doing indefinite integrals. And then my final step, so that was my integral step. My final step is to substitute things back in. So I will get tangent, my u is x plus 2, so I'm replacing that, and I'll get plus c. So that is my answer for this one. Okay, we have a couple more. So example 3, they're getting a little bit harder. So both of those problems were pretty simple ones. These next ones are going to be a little harder. So example 3, reverse chain rule, still medium problem. So now we have like multiple things in parentheses, and so the question is here, like, which one do we define as our u, right? We have x minus 1, and we have this one right here. And the trick to this one is, which one is u? Normally, I mean, it's which u, right? Normally we kind of think, okay, what's inside, but there's not really anything inside here. But I like to think with u's, which one could I possibly take the derivative and it would help me cancel out the others? And so you guys haven't done a problem like this yet, but you'll see. If you guys imagine this, if I take the derivative of this, I'm going to get 4x minus 4. And that is going to help me get rid of this part here. So in a sense, this isn't always going to work, but you're going to choose the more complicated function. More complicated function if you have a choice, and some of the last problems was very obvious what u was, but this one it's not. So I'm going to choose the more complicated one, and that is 2x squared minus 4x, and you'll see again, like y, I'll take the derivative of u, and that gives us 4x minus 4. Again, I solve for x, or I solve for dx, but essentially we're just switching these two people's places. That's what we're doing when we solve. So I'll get this function that equals dx. And now I shall do my substitution step. So x minus 1 for right now is still here because I haven't done anything to replace it. But this expression down here gets replaced with u. So it's going to be u to the 5th power. And then dx is being replaced with du over 4x minus 4. And the problem is we can't integrate with respect to u's if we still have x's, because x isn't a constant, x is a variable. And so we need to do something to figure that out. But watch this magic happen. If you guys look at this function, you might be like, oh, these are similar, right? They're the same, almost the same thing, but these have 4s. And so what I'm going to do is I'm going to factor out the 4. I'll be left with this expression. These cancel out. Not the 4. I shouldn't have erased that much, but the 4 doesn't cancel out, but everything else cancels out. So now I have du over to u to the 5th power times 4. And so now everything's with respect to u. We got to get, so one thing that we have to do real quick to just like make this easier to solve is this is on the bottom of the fraction. To use the reverse power rule, we need to get it on the numerator. So this is going to become u to the negative 5th power all over the constant 4 du. Now I'll actually take the antiderivative, so no matter what happens, 1/4 is just a constant, and then this will be u to the negative 4 power over negative 4 plus c. And then in this next step, I'll clean this up real quick, so this will be negative 1 over 16 u to the 4th power plus c. And my last step is I plug everything back in. Just like that. And so that is, I have to put my exponent back too. So that was, my new exponent, which is 4. And so that is the integral of this big function over here. Okay, we're going to do 2 more problems and then we'll be done. This next one, again, is a little bit of a harder one because you just don't know, okay, which one should you use? And so basically the big idea when you're thinking is do one of these functions, if I take the derivative, cancel out the other. So, for example, our 2 options here are, the 6 isn't an option, right? We know that that's more of an outside idea, but we're basically choosing between x and the natural log of x. Well, the derivative of x is 1. That's not going to do anything to help us cancel out the natural log of x. And the natural log of x's derivative is 1 over x. And so that is actually going to help us. So I'm going to start. U is going to be the natural log of x. The derivative of u with respect to x is 1 over x. And so now I will start using u substitution. So the natural log of x becomes u to the 6th power over 6. Remember what I'm doing is I'm just doing like du over 1x. I'm flipping these guys places. Just to simplify this up real quick though, du, anything divided by like 1 over x just ends up becoming multiplication. So that's what's going to happen there. So I'm going to come and replace my dx with x times du, just like that. And then watch this. Cancels out. Amazing. And so if you choose the wrong u value, you'll know really quickly because you'll have part of your equation that won't cancel out. And so that's what's good to know here. So now I'll actually take the integral of that with respect to u. I'll get u to the 7th power over 7 plus c. So that's what this equals. And then I'll plug everything back in. So it'll be the natural log of x to the 7th power all over 7 plus c. So that's kind of more of a medium problem where it's like not too hard to figure out, but you do definitely have to pick between more than one function for what's your inside function. Last one, this is a hard one. So the inside function for this one's probably obvious, right? Like this is inside the other function, but we might not immediately see how this will cancel this out. Because if I choose u to be my inside function, x minus 1, the derivative of that is 1, and that's not going to cancel out this x. So just bear with me, right? Because x, just like the x out front, is not a good option either. So this is going to be a trickier problem, but it is going to work out nicely, and you guys are going to love it. So my inside function is going to be x minus 1. If I take the derivative of that, I get 1. So that makes me find that du just equals dx. So I can just like do a direct flip. But now watch what happens. We already talked about how this is going to be a problem, but what happens when I plug things in? I'll get x, then I'll get the square root of u, because I replace x minus 1 with u, and then I get du. So the problem is, like, I got u's and I got x's, and we're integrating with respect to u's, so we are only allowed to have u's. So what do? Everyone think, pause, feel free to figure it out. But I will tell you. So if you guys look at this, what we defined as u up here, it's a pretty simple equation. It's just u equals x minus 1. So watch what happens when we solve. What if I wanted to solve for x? All I would do is add 1 on both sides, and I get u plus 1 equals x. And so that actually could help me here. So what I'm going to do to get this x, to make sure we only have u's, to get this x in terms of u's, is I'm going to replace x with u plus 1 times the square root of u times du. Now you might be like, okay, that doesn't help me find the antiderivative. I still have this product. I still have these functions. Well, real quick, let's put this u into integral, or not integral notation, exponential notation, right? And we have a product now. And we're not allowed to take the integral of a product, but we can use the product. Like we can actually do the product before we take the integral. So that's what I'm going to do. I'm going to distribute essentially u to the 1/2 power here. And I'm going to use my properties of exponents to do that. So if I do u times u to the 1/2 power, all you do when you multiply variables with exponents, you just add their variables as long as the exponent's the same. So this becomes u to the 3/2 power. And then 1 times u to the 1/2 power is just u to the 1/2. And we're not done yet. Now we actually have to take the integral. We just got it in a form that allowed us to take the antiderivative. And so u to the 3/2 power is going to be u to the 5/2 over 5/2 plus u to the 3/2 over 3/2 plus c. I will simplify and then I'll substitute things back in. So this simplifies to, I'm just going to leave it in exponential notation since it's so ugly. And then this becomes, now I can put u back in. And remember from here, u is x minus 1. So I'll get 2 times x minus 1 to the 5/2 power over 5 plus 2/3 x minus 1 to the 3/2 power plus c. And that is our answer. And that's all we have today. Hope you enjoyed those easy, medium, hard problems. We will practice more in class. Have a good day.